One of the great features of SonarQube is that it gives visibility to your technical debt. This importantly includes test coverage. One could argue that without test coverage, there isn't as much value in looking at the issues that Sonar reports, as without tests there are few guarantees that making changes to the code won't introduce a regression issue. So here, digging into coverage, we can get an overview of what parts of our code have been tested and what parts of our code have not been tested. The red line here indicates the code has not been tested. The green bar here indicates that the code has been tested. And the orange bar here indicates that the code has partially been tested. So in this case here it's suggesting that some of the statements or some of the if-else conditions here have been tested and some have not been. So we've been working with teams on how to get tests for IRB. I won't go into the details of the methods to collect and report coverage. There are other videos available on our website for that. I'll be looking at how to make it easier to get unit test coverage working, or how to make it easy to get unit tests. Developers and testers can test a flow end to end, and it is valuable to collect that interaction as an automated test or an integration test. But once you start generating test coverage, you start looking for the gaps. Integration tests are valuable in that they are more closely aligned to the user or system needs, and they often help, or the interaction that they record often helps confirm requirements that can be presented back to the business or back to users. But they can be difficult or hard to set up. So we've been helping teams with unit testing. The code below shows a hard-to-test version of the code. To test this code, the input and output needs to be set up and read. In this case, the input root, and you would read the output root in the result. To test this code, the input and output root needs to be set up, which is hard. It is also hard to test this code more than once, as the input and output roots from one test are likely to interact with the input and output roots of another test, or the environment from one test is likely to impact the environment from another test. So this version of the code is more testable, and later we'll show you below some unit tests and see how it was tested. But in this case here, we can see we still have an input root, in this case an input reference, and an output root, in this case an output reference. The same logical flow is occurring through the code, but rather than writing to the input root directly, we're writing to the input reference. And same with when we are writing to the output root, we're writing to the output reference, and we're reading from the input root, we're reading from the input reference, rather than directly. So this is what our refactored main looks like. We still have our copy message headers. We're referencing our input root and we're referencing our output root, and then we're making a call to our business logic in the same way. So there's very little change to the actual business logic. The only difference is we're referring to references rather than directly to the input and output root. So we're able to inject the input root and output root via a reference. Now this here is a unit test example that executes that logic that we have refactored here, or separated out here. So now we can actually write some unit tests for that ESQL using the references that we're going to create to pass in. So in our first test case, we're going to set up an environment or a section in the environment to capture the input and output. We're going to create the necessary elements within the input root that our test requires. We're going to create the reference to the input and output as required. Then we're going to make calls to our logic, and then we're going to assert or validate the results of our logic. So in this case here, we're checking to see that the postcode was correctly mapped. If the postcode is correctly mapped, we're putting a test result in to say passed. If it was incorrectly mapped, we're putting a test result in there to say fail, with the expectation that had failed. So now we're able to do multiple tests of the same logic to test different parts of the code each in isolation. So now we have our 4 unit tests created here. We essentially need a way to include them in our process. We need a way of triggering them or executing them. So what we've created here is a fairly simple flow, just a flow that accepts an MQ message on a queue. In this case here, the queue is unit test 1 in. We write this results to unit test 1 out, and then we've just basically got a main that calls our 4 tests. Those 4 tests in turn call our logic, producing some results, passing or failing. The next step then would be for whatever triggers this flow, which triggers our unit test, would just need to go through the results and the output message, go through the XML to see if there's any failures and what the failure message is. And if a failure occurs, then report back to the developer of the test to say that the unit test has in fact failed. So in this case here, the refactoring of this logic has been done manually, but what we'd like to do is get from doing a manual refactoring of the code to make it testable to being more automated, or something that can be reproduced more easily. And so that's what we've been looking into. What we've done is looked into automate the task of refactoring the code to make it testable. So the idea is the developer spends more time writing the tests and the logic rather than the plumbing for the plumbing of the test factory. That also hopefully means that the test logic and the business logic is written in a more consistent way from developer to developer, so it's a little bit easier to identify, to understand what the code's doing and identify what the code's doing, because it's more of a similar pattern. So let's have a look at seeing it run in action. So I've just switched over to a slightly different project. So we're looking at here is a sample project from IBM. So you can see here these standard copy message headers. We can see that we're updating the output message from something in the input message. We're looping through some logic and eventually returning true from the main to indicate that we need to propagate the message. So fairly simple message translation logic, but not so easy to test. So what we're going to look to do is we're going to look to run our refactoring tool over this, and then I'm going to refresh the toolkit just to see what the new version looks like. So I've run our tool, basically just given some output. I've just cut and pasted this output here to indicate what it's done. So basically it says it's found a file, it's refactored the file, and made a backup of the file of what the original code was. So we can go back to the original code just to make sure that the updated logic is consistent with what we're after and what we're expecting. So now I'm going to refresh my toolkit with the updated code. And we can see the code's it's switched in the new code. So what we're going to do is let's have a look and see what it's actually done. So we can see we're still in the same schema, but now we have a new function or a new procedure in our code called order list to purchase data compute process logic. So you might just recognize a pattern here. Basically, it's what the original procedure in the main was called, with process logic at the end. And we can see here we've passed in an input reference, an output reference, and an environment reference. We can see here that rather than writing to the output, we're now writing to the output reference, and rather than reading from the input, we're now reading from the input reference. We're doing similar logic. We're iterating over the input. We're looking at the number of records. We're going through creating a reference, an output reference again, writing some output records. At the end of it, again, we've indicated yes, we want to propagate the message. Our business, our main compute modules changed slightly. So we now have the same order list purchase data compute with copy message headers, but we've had some extra lines included here. We've got input reference, output reference, and environment reference been set up for us. We're expecting a result. From our function, and the result is going to be returned to indicate whether or not our main flow should propagate the message onto the next component in the flow. We've kept the copy message headers, and we've tried to keep the comments as much as possible. The code may have a slightly different formatting, just because we've moved code up and down and around, so the indentation might have changed slightly. Okay, what we've also got now is we've got a test. So the test itself doesn't have any logic, but it does give us a good template. So in this case here, if we were going to look to extend this generated code to make it useful for testing, we might keep it. Might call it test purchase order 1, for example. To give it some meaningful names, and so on and so forth. We could now then go through and fill in the appropriate pieces of data that we're expecting to go in. So we might have, in this case, it's generated as a template for XML. We might be looking to create some DFDL. For example, using the purchase order structure, for example. So at this stage, we've generated a template for the testable code. We regenerated the testable code. We're not at the point with the tool where we can generate test cases, but that may be something we'll look to in the future. But in the meantime, it does give us a good standard template for writing and reproducing more test cases. So in this case here, this might become purchase order test 1, and then we would replicate those tests as we do more and more unit testing of this module to find more and more paths through it. Thank you for joining our brief demonstration. If you do have any questions, or you'd like to see a proper demonstration or interactive demonstration with you and your team, please drop me a line. Please drop me an email or contact us via our contact page. So our contact page is bettercodingtools.com/contact. Just add your email details and we'll get back to you. Thanks again for your time, and hopefully you found this presentation useful.